Hello, everyone, and welcome back. I'm Quentin Anderson, and this is Real Time Talk with Eagle 3D Streaming. Today's guest is Johan Polhem of INVNT. He is the executive director, and he is a leader at the very forefront of immersive technology. As the executive director of INVNT Innovation, he spearheads cutting edge initiatives that push the boundaries of spatial computing in all of its forms. With a strong background in VFX technology and content production, Johan combines strategic foresight with hands on expertise to deliver groundbreaking solutions for global enterprises. Johan, how are you doing today?
Hi, Quentin, and thanks for the intro and thanks for having me. I'm excited to be here.
We're very excited to have you as well, and definitely appreciate you taking time out of your busy schedule to be with us. Let's dive right in. It would be nice to learn a little bit more about your technical background and some of the projects, and some of the technologies, and just a little bit more of your work history and how you kind of got to where you are today.
Absolutely. So my background is probably a little bit unusual for how I ended up where I am. So I started in visual effects and animation. So I've been quite deep into different 3D software and 3D workflows for the past 20 years. I had my own production and post-production company that I sold about 10 years ago. And since then, I've worked for different ones. I was the managing director for Fin Design in Sydney and Singapore. And I got to a point in the visual effects industry where I realized that I've sort of gotten to a point where there wasn't that much more to learn. And I didn't see a very bright future for the visual effects industry. And this was 5 years ago. You could kind of see the writing on the wall with visual effects becoming a commodity in many ways. There was always somebody cheaper who could do a job almost as good as you or good enough. The introduction of AI has made that even more competitive. So I made a conscious decision to look at what other areas could I use my skills in 3D and production and 3D pipelines and workflow. And I also forgot to mention, I also have a degree in computer science. So I always wanted to go a little bit deeper into the tech side of things. So I was fortunate enough to join INVNT as they were setting up an arm of the business focused purely on immersive technologies. So they had built their own, before I came, they even built their own startup internally, which was basically a metaverse mall or a mall in the metaverse. So this was in 2019 when the word metaverse was still cool. And they were deep into blockchain and things like that. So I sort of jumped into that. I had a pretty steep uphill learning curve for the first sort of year and a half to wrap my head around how this technology works. I had half of it, so I understand the 3D production. I understand Unreal Engine really well and all the other 3D softwares, and I understand how they work and how to build the pipelines. But the whole other part of it, which is interactions, interactivity, avatar creations, game engines, and running those in real time between different users, that was new to me. So that was the uphill battle, but I eventually got there. So it took a while to wrap my head around, but I feel like I'm starting to get a hang of it now.
And I know that you kind of mentioned that VFX is sort of going through this commoditization a little bit. What are some of the differences you've noticed in the immersive world? Do you think that it's just a little bit newer and it'll eventually kind of have also the same thing that VFX is going through, or do you think that this type of experience, the immersive experience, is inherently different than VFX, 3D artwork, some of those more traditional forms?
That's a great question. It's hard to say what it's going to look like, a few years from now. But I would say that the main difference is that the barrier of entry is much higher in the immersive space because it is much more complicated to build a cloud stack with a game engine to run experiences in real time than it is to, for example, set up your own 3D company, which you can do off a iPad basically now, or post-production company. So yeah, the barrier of entry is much, much higher. It's harder and it's more technical. And that, it may become easier to compete when there are more tools for automation. But right now we're still in the process of the tools aren't quite ready yet. So I don't think that's going to happen in the short term.
And I know you mentioned cloud stack when we're thinking about immersive technologies, and I know that you also have experience with pixel streaming and WebGPU. When you're creating these immersive experiences, what are the different ways that you've deployed? Have you only done pixel streaming or WebGPU, or have you done desktop experiences? Have you done experiences for Apple products? What are the different types of deployment that you're familiar with?
Sure. So if you look at what's been happening in the last few years, there's been a lot of developments. So about 2-3 years ago, we did almost everything pixel streaming. So we would build a stack with sort of a game engine at the center, generally Unreal Engine, because that is, or was at least at the time, the engine that gave you the best quality. And you sort of put a stack together with all the different functionality, and then you would pixel stream that. So we did a lot of those. We've done the WebGPU, as you mentioned. We built experiences. Sometimes we've duplicated the experience that we've had in Unreal Engine, and we duplicated it to make a WebGPU or WebGL2 version of that experience, sometimes to test it, but sometimes also to offer an experience that is cheaper and doesn't have the latency issues that's inherent with pixel streaming. But the last sort of 6 months, we have been going quite deep into the Apple Vision Pro and the Vision OS operating system, which has been really successful, in my opinion. It sort of removes the problems that are inherent with pixel streaming and web GPU when you want to scale to a larger audience or when you want to add functionality. I still think that pixel streaming is excellent for certain use cases, and it can only be done in pixel streaming. But I think for the vast majority, when it comes to training and collaboration, you can get a lot better results out of an Apple Vision Pro, even though the headset is obviously very expensive, so might not be suitable for everyone.
Yeah, and I definitely want to dive into the Apple Vision Pro and learn more what you're kind of experimenting there. And I'm also curious. So you started using pixel streaming and WebGPU for delivery. How do you remember how you ended up deciding to deploy to a browser versus maybe just like a desktop experience? Do you remember sort of the reasons why you decided to use a browser versus, well, hey, let's just send them the build file and they can play it on their desktop locally?
Yeah, no, absolutely. So yeah, it's when you build these type of experiences for large enterprises, for them, one of the most important things is accessibility and security, of course, but accessibility is key. So if you want to run something which is any device, anytime, we can't really build an application that you download. When you want to build something that can be accessed from anywhere at any time on a mobile phone or a tablet or a laptop, you can't have an application. You have to run it from the cloud and then into a browser.
Yeah, yeah, exactly. So I guess it's more of, or I guess accessibility is kind of the reason why a browser would be used versus like, creating an iPhone deployment method or a desktop deployment method. It's just easier for people to access the content.
Yeah, absolutely. It becomes a huge barrier for some organizations if you build an application. Sure, if everyone in that organization has an iPad, for example, from Apple, and it's the same iPad, then it kind of makes sense maybe to build an application, but that's very rarely the case.
Right, right. Everyone's going to have their own device of choice, and it's never going to be the same. So it's kind of difficult to plan deployments in that kind of scenario. When
That's right.
what was the use case that pixel streaming was used for? Do you recall just kind of the requirements and how you guys chose pixel streaming over everything else?
Yeah, I can't divulge who our customers are, but we've had two recent very large use cases with pixel streaming, and the reason why we picked pixel streaming over WebGPU was threefold actually. Number one is the quality. So the quality that you can get streaming Unreal Engine is much higher than you can get, running WebGPU in a browser. Then you have the security concerns. A centralized security that sits on the cloud is safer than something that sits in your browser, which is it's a bit of a weaker link in the chain. And then the last thing is functionality. When you build something out of Unreal Engine, it comes with inherent and inbuilt functionality. You can probably do some of it if you build a play canvas or a Babylon or WebGL, but you can't do all of it. And even if you did, it would be insanely difficult to build it. Because, all these things they sort of come with a package when you use Unreal Engine.
Right. And some of those functionalities could be something as simple as like a navigation style. If it's a digital twin, then being able to fly around a city, but also being able to have some sort of gimbal and rotate and pan around a certain area of focus. Or are you talking about those kind of game mechanic functionalities that are where Unreal Engine shines?
Yeah, well, definitely game mechanics is one of them, but there's also communication tools. It's how you communicate, because a lot of these experiences are about collaboration. So when you build a stack on the cloud, you can sort of add through APIs different communication tools. I mean, you can even incorporate Microsoft Teams or Zoom, or you can present videos baked into screens that run on PowerPoint. Like, there's so much more you can do from an enterprise point of view using pixel streaming that you just cannot access with a WebGPU, at least not that I'm aware. I would imagine that would be extremely hard.
Right, exactly. And let's talk about WebGPU a little bit, because I know that you've also experimented and also, or have you done a live project with WebGPU, or has it mostly been experimental learning with the technology?
We did some earlier on when I started, but we haven't used it lately, and we have still been experimenting with it because we always want to push the boundaries and see, especially with the difference between WebGL, WebGL2, and WebGPU. We sort of wanted to see, okay, if we take this environment, this experience that we have built in Unreal Engine, and let's rebuild it in WebGPU and compare what happens. What does it look like when you push it all the way to the limits? So we always know that whatever technology we choose for a project is the most appropriate. So to do that, you need to see, of course, what is it, what can it achieve, but also what can it not do.
Exactly. And so was that just getting into WebGPU, was that just kind of to experiment and to learn about other technologies, or was it a reaction to the limitations of pixel streaming, or maybe a little bit of both? Or how did you get into WebGPU?
That is a great question. We found it was a little bit of both. So the main challenges we've had, and I think everyone has had with pixel streaming, is number one, it's not scalable. It's linear scalable, right? So if you have 10 users and then you want to add another 90, it's going to cost you 10 times more.
Right.
It's not going to cost you a little bit more, because for every user, you need the same amount of compute power in the cloud. And compute power in the cloud is very expensive. Now, if you only have a few people using it, or you want to do just a couple of complex simulations, but with a few users, that's fine. It doesn't really matter, because the cost is not going to be a challenge. But when you have thousands of users or even hundreds of users, the cost of pixel streaming becomes astronomical, and it doesn't stack up as a business case. And the other issue is you can get latency depending on where you are, and you can run into challenges with actually accessing available GPUs. If you want to have it completely elastic and you have 10 users and now another 90 users are going to jump on, you might have a problem finding those GPUs. It could be waiting times. So there's some challenges that comes with inherently with pixel streaming that you don't have with WebGPU. It's kind of the inverse. So you don't get the quality, you get really low quality, but there is no latency and it's completely scalable. So what's the idea that you could scale it to a huge amount of users without adding that much extra cost that led us to try and explore WebGPU a lot more?
And do you think it's an oversimplification to say WebGPU is more for like B2C applications where you have a high number of users that need a very quick, responsive, low latency experience, and pixel streaming is B2B applications where there's a low number of users and they need access to very complicated data? Or what do you think some use cases for WebGPU and pixel streaming could be?
I think that's a really good way of looking at it. To your point, B2B with pixel streaming, let's say you have a digital twin of a factory with really complex simulations and you have 10 users, it makes a lot of sense. You say you want to automate a car factory and you want to test what that would look like. So pixel streaming makes perfect sense and the quality is really high. But to your example, if you want to go B2C, you can't use pixel streaming. It'd be way too expensive. But WebGPU might make sense because you're not running a business critical simulation. You're probably doing, I don't know, marketing gimmick or something like that, where you don't need the high quality, but you want a huge amount of users. So yeah, WebGPU would make sense in that case.
And something that I hadn't thought of, but I started thinking about when you mentioned it, is the functionality when it comes to WebGPU. So especially with collaborative tools like integrating a Zoom into a WebGPU application, I hadn't even considered this, but it sounds like it would probably be very or challenging to have a Zoom call through a WebGPU experience.
I have never tried and I had never gotten to the point where I wanted to try it. I mean, it might be possible, but yes, it would be very complicated. And it's not the type of use cases that make sense with a web GPU. It's just not the type of experience. It's more game-like, it's simpler, it's low quality graphics. So it's probably, a marketing gimmick makes perfect sense. But not communicating with your colleagues.
Right. So collaboration may be off the table, and more of just a communicating information through 3D data.
Yeah.
Are your clients typically the ones where you're delivering high fidelity experiences for? And is that why you sort of looked into AVP, or what sort of led the charge in getting into Apple Vision Pro?
Yeah, sure. So the type of customers that we work with and the type of use cases that we generally do they need super high quality. That's important, but it also needs a lot of functionality. So, and lastly, unfortunately, that also needs scalability. So there is currently, before the Apple Vision Pro, there was no way to get super high quality with functionality and also scalability.
Right.
Because you can get scalability with WebGPU or you can get okay quality with pixel streaming, but you can never get both. It's a limitation of the technology. That's why we have started exploring Apple Vision Pro a lot more, because it is completely scalable. It's actually cheaper to develop on and much faster to develop on, and it's got none of the limitations. The quality is maybe tenfold compared to what you can get in a pixel streaming scenario, and you can get multiplayer, and you download the application onto the headset, so there's no cloud costs. The only thing you need is okay internet, and you're ready to go.
And are you running those offline on the Apple Vision Pro, where you'll where essentially everything's being rendered on the Apple Vision Pro itself, or are you actually doing some of the rendering in the cloud and it's being streamed to the Apple Vision Pro?
Great question. So we don't render anything on the cloud because there's no need. Yes, you can run it offline, but when you run it offline, obviously you cannot get multiplayer functionality, but you get everything else. So if you want to run multiplayer, the beauty of, again, the Apple ecosystem and Vision OS, it runs in SharePlay, which is basically FaceTime. and you can run the multiplayer functionality through that. So if you both have the app, if you have a headset and I have a headset and we have the same application, we can meet in there and I can start moving objects around and you will see that in real time. But none of it has to be rendered in the cloud, which means that you could scale it up to thousands of users theoretically and it would cost almost nothing.
Right. Because as long as everyone has an Apple Vision Pro, then there's really no back end cost. And if some of the users are scratching their head, we're wondering why is there so much cost with pixel streaming, you essentially need one GPU running on the back end per user. So if you have 100 users, then you need 100 GPUs, and you get charged by the minute, by the hour, by the cloud companies to run them. So it sounds like what you're saying with Apple Vision Pro, you just run it client side or on the Apple Vision Pro, and there's no compute cost associated with it unless there's a multiplayer experience. But multiplayer servers are nowhere near expensive as as GPU servers.
Well, you don't even need a multiplayer server because it all runs via SharePlay, right? So you don't even you need there's nothing on the cloud unless you feel like you want to do like a cloud login or something, but you have nothing on the cloud. It's all they communicate directly with each other through the internet, through SharePlay, which is FaceTime. So yeah, there's nothing at all in the cloud, which brings down the cost significantly because sure, the headsets are expensive. But when you look at, to your point, when you look at the cost of pixel streaming to a large numbers of users can get incredibly expensive. You can look at anywhere from $5 to $15, $20 if you're going to add Cloud XR and up and downstream and then hit video streaming inside of it. It becomes extremely expensive and you can be up in the hundreds of thousands per month just in pixel streaming costs if you have a big user base. So a headset that costs you a few $1,000s is money you will save very quickly. And I have seen now that Apple are most likely developing cheaper headsets, which come with really strong chips built in. So even the cost of the headset is going to be a non-problem soon.
Yeah. And so here's a very, very tricky question. If you look into your crystal ball, do you think eventually client side rendering will prevail or server side rendering? Or it'll maybe depend a little bit?
I think it's going to depend on the type of use case. Like we spoke about before, if you need to do a quite complex simulation that requires more computing power than you can get in any one headset, yeah, you're going to need to do it on a server, right? Or on the edge even. But you're not going to be able to do that on a headset. So I think it's going to be split up between the type of use cases that you have. But if you're after learning in a multiplayer scenario or collaboration, that's most likely on device. Anything more complex will be cloud, served via the cloud, I think. And that's just a guess because technology moves so fast, it's impossible to say.
That's so true. And yeah, and another thing that also made me think a little bit is the security aspect. And sometimes it may make sense to run things on the server side just because an organization needs data hosted locally in maybe their own environment or in a cloud environment, and which is more secure because you're really just sending a rendered MP4 to the user's browser rather than the actual data. So security could also be a use case as well.
No, absolutely. And I think that is a weakness with web GPU type solutions. It's not very secure. Whereas you can build a cloud stack that has a lot of security. Even if you use an Apple Vision Pro, it comes with Apple's security, which is also robust. But yeah, security challenges with web GPU are quite big. And I think potentially that the type of web GPU type of solutions are going to suffer more than pixel streaming and device rendered solution.
And when we compare WebGPU to WebGL, what is the selling point for WebGPU? Is it that it's more efficient, so you can use more graphics or GPUs to run a WebGPU experience, or is it more of maybe more high fidelity, or what's the selling point of WebGPU over WebGL, would you say?
Well, from my understanding, the selling point is that WebGPU is much more efficient in its communication with your device GPU, which results in much higher quality graphics, which means you can introduce things like dynamic light and surface reflections and things like that, which are very hard to do in WebGL. So it is an improved version of WebGL, but the step from WebGPU to pixel screened Unreal Engine is still, it's a huge step. It's not, it doesn't really scratch the surface. I've seen some pretty decent solutions in WebGPU, things that look okay, but the issue is that you have to download all those assets to your browser before you start using them. So if you load one of these WebGPU experiences, you might be loading for minutes before you can even start. And even then, it's going to be a little bit clunky.
Yeah, yeah, and we experienced that as too on some of our experiences where you've got this huge package that has to be downloaded first and then extracted before you can actually run a web GPU experience. But I love your point. It really just depends. You've got to think about your use case, and then it's always picking the right tool for the job.
Yeah, that's right. I mean, to a point, we've had the same issue sometimes when you use WebAR. In theory, you can make gorgeous WebAR experiences on your mobile phone, but it also has to download everything onto a browser, right? So, and people don't really want to download a whole application. If they downloaded a whole application, you could make amazing WebAR experiences, but that's just not how the technology is used.
Yeah.
So it comes with similar limitations.
Right. And I know we kind of talked about this offline. It's totally theoretical right now, but there are some applications like DLSS, which is now up-resing using AI. Any thoughts or totally theoretical on how AI could play into the world of rendering?
Look, we deploy AI for certain parts of the workflow. I think AI makes a lot of sense when it comes to, for example, optimization. So if you're going to work in a software like, okay, let's say Unreal Engine, you're still going to have to bake surfaces and bake textures and, be smart about where you use your GPU real estate. I think an AI can probably more efficiently delegate that. And you can probably automate a lot of that because that work is tedious and boring and time consuming. When it comes to the web GPU, which is in dire need of optimization, there might be a way for AI to not only optimize, but theoretically maybe even up-res in real time. I don't know if that's possible now or in the future, but maybe. When it comes to the Apple Vision Pro, we use it obviously for automation of the 3D pipeline as the main tool and for coding and things like that. So I think it's helpful. I don't think, at least not now, it's not a magic bullet to make web GPU as good as pixel streaming. I don't think we're there, but I'm not an AI, coder, so I can't say where it's going to head in the future.
Yeah. And to your point, I mean, it's changing so fast that, the tools and available and how we think about them may change in just 6 months, 3 months. And I know we're already kind of running
exactly
to our half hour. Again, thank you so much for swinging by. Is there anything else you'd like to share with the audience, or if someone has a question, is there a way to contact you afterwards?
Yeah, absolutely. Hit me up on LinkedIn.
Cool. Johan, thank you so much.
I'm easy to find. So yeah, just message. Yeah, sorry, I interrupted you.
So please find Johan on LinkedIn, and thank you again so much for taking time out of your day to join us. We really appreciate it. This has been Quentin Anderson with Real Time Talk with Eagle 3D Streaming, and we will catch you all on the next show. Thank you, Johan.
Thank you very much for having me. It's been a pleasure.